good afternoon or morning. I don't remember. Point is, it's good to see you all, which is to say, not see you all. I'm gone. I told you guys my kids get sick regularly, and of course, they get sick on the day when we get to divide polynomials. I hope you're as excited about this as I am. To make up for my absence, we're going to watch a video. Please do your best. Follow along with it. If you get stuck, ask the sub to pause it, rewind it. You can do that. If you're not comfortable with that, or you would just rather work on your own, check your Remind app that I hope you all signed up for. And if you haven't, look up by the calculators and get signed up. In there, I sent you guys a link to this video. So check it out there, plug your headphones in, and use those phones for good, not evil. All that said, let's jump into this. Sidebar, just as a fair warning, it's 11:30 at night, and I'm tired. So if I say something a little silly, bear with me. I'm doing my best. I know you will too. Let's go. First, vocabulary. Dividend is the number, or in this case, the polynomial that we are dividing. Divisor is what we are dividing by, so that's this one here. And once we do the division, we end up with a quotient. It's like the equivalent of a product or a sum or a difference. We now get quotients when we're dividing. It's nothing new, but we don't use this language very often, but we will be using it in this section, so I want to make sure we're clear. Now, with dividend divided by a divisor to get a quotient, we'll also, of course, see it as a fraction. This will be the most common, especially moving forward after this section. And they will also occasionally use this notation to show division, which is multiplying a number by its inverse, or by its reciprocal, which is the same thing as division. All of these, all of these are different ways that the homework will write different dividing polynomials problems, and I want you to understand that no matter how it's written, it's the same process. Now, to start the actual division, we'll start with the simpler part, which is a polynomial divided by a monomial. Okay? In this case, as it says over here, we are just dividing each term of the numerator by the denominator. So the denominator is just 4ab, and now we're going to take this first term divided by 4ab, the second term divided by 4ab, and the third term divided by 4ab. If we can, pause the video now and just see what you come up with. Write what you think it would be down in this space, and then we'll come back and I'll kind of walk through how it should look. Okay, so if we look at this, again, we take 16 divided by 4, and that's 4. A to the 8th over A, subtract your exponents, A to the 7th, B to the 7th over B, B to the 6th. Hopefully this matches what you came up with over here. Second term, do the same thing. 40 over 4, 10. A to the 7th over A to the 6th, B to the 6th over B, B to the 5th. Okay, hopefully that matches your second term. And then finally, we get negative 12 over 4, which is negative 3, A to the 6th over A to the 5th, and B to the 5th over B, B to the 4th. Okay, so hopefully you guys were able to get that one. And if not, just notice what I did. Okay, you're still just dividing the coefficients and subtracting the exponents, just like we did on the previous 2 days. You just have to do it more than one time in one problem. It's nothing new, just doing the same thing more than once. You'll find that a lot the deeper you get into math. The next step is just do it more than one time in one problem. Okay, take a moment, ask for a rewind if we need it, and then once we're all good, we can move on. Okay, now for the rough stuff. This is something new that we haven't seen before, and this process will seem complicated, but once you've done it 2 or 3 times, it goes a lot smoother. And when I get back tomorrow, knock on wood, I'm going to show you an even easier version to do it that's more useful in certain circumstances. So we'll go through this long division, and like I said, touch base on it some more tomorrow. The idea with the long division is it works just like old long division. So long division when you were in elementary school, and you would do like, what's 187 divided by 16 or something. We're going to do that same thing. It's just now, instead of using regular numbers, we're going to be using polynomials. So we'll have an example like A here, where we get a squared plus 3x minus 10. That's our dividend. and a divisor, here written in that inverse form, of x plus 5. And we're going to write it just like we used to back in elementary school, okay? We're going to get our big number underneath the house and our little number up the front door, up in front of the house. We'll just say that, okay? Here's the divisor, here's the dividend, however you want to use your prepositions for this metaphor. And just like we did with regular long division, we're going to ask ourselves, how many times does this first number, in this case x, go into this first number, in this case x squared? And a really simple way to think about this is to actually work backwards. If you can't look at this and go, x times what is x squared? Look backwards. X squared divided by x is x. Okay, that's what goes there. Okay, and the way I check myself, and I do this for every step to make sure I'm doing this right, is I again work backwards. X times x is x squared. That should happen every time for these problems. If it doesn't, you're doing something wrong and you want to check yourself. So I've got my x lined up on top of my x terms. X times x is x squared, and I write it there. Then I do x times 5, also just like I would do with long division, and get 5x. And then also, just like with long division, I'm now going to subtract. And the way the subtraction works is x squared minus x squared is 0. It cancels out, it goes away. But what's 3x minus 5x? Negative 2x. Okay? Now, that's kind of like my remainder, but then I bring down this next term, and I repeat the process. We call this an algorithm because an algorithm is any kind of process that you can repeat over and over again until you solve a problem. And in this case, we're using an algorithm. We're using the polynomial long division algorithm. So I asked myself the same question before. X times what is negative 2x? Or vice versa, negative 2x divided by x is negative 2. Multiply it out. Negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. And we will hope that once we do this last step, you'll notice these two guys are the same, which means if I subtract them, negative 2x minus negative 2x is 0. Negative 10 minus negative 10 is also 0. So this whole thing comes out to 0, which means I'm done. Okay? If I get down to this point where I've got nothing else over here to drop down, there's nothing there, and I get a 0, then I'm completely done. I've got my quotient as being x minus 5, or excuse me, x minus 2, and there's no remainder. You guys remember remainders? We'll probably talk a little bit more about remainders when I get back, but yeah, we don't have to worry about that. This one's all set. We're all done, and that's all it's asking for. Okay? A good time to pause. You know, do your best to make sure you got this one square. This is a good one to go back and watch again. Make sure you've got all the notes down. And then I'll show you example B, which is a little bit longer and has one last curveball that I'm going to throw at you guys today for this video. Okay? Now, here we've got a slightly longer dividend, x to the 4th plus 3x cubed plus x minus 8, and then we're going to divide that by x plus 4. Now, underneath, we still put that dividend, but I want you to take special note of this right here, okay? This 0x squared, it's called a placeholder, and we talk about it right here. You cannot forget that 0 placeholder when we're doing these polynomial long division problems, okay? I will explain it a little more in person why it's so important, but for now, just understand, if I've got a polynomial that has x to the 4th, x to the 3rd, no x squared, but then x to the 1st, and technically an x to the 0 here at the end, I gotta make sure I put that x squared term with a 0 coefficient there. If I don't, it throws the whole problem off and we'll end up with an incorrect answer. So make sure you get that. Divisor still goes up front, and we start going in. X times what is x to the 4th power? We just get x cubed. X cubed times x is x to the 4th. Perfect. And x cubed times 4 is 4x cubed. Come back here, subtract. X to the fourth minus x to the fourth is 0. It cancels out. And 3x cubed minus 4x cubed is negative x cubed. Okay, so far so good. Now drop down the next term and we get plus 0x squared, which is fine. The 0 is fine. We need that 0. Come back up here. Repeat the algorithm. X goes into negative x cubed, negative x squared times. Again, if you need to, work backwards. Negative x cubed divided by x is negative x squared. Check yourself by multiplying. Negative x squared times x is negative x cubed. They match. Negative x squared times 4 is negative 4x squared. And subtract. Negative x cubed minus negative x cubed. Good, they cancel. And 0x squared minus negative 4x squared. Uh-oh, minus a negative. Don't fall for that one. Positive 4x squared. And now it's time to bring down the next term. I'm going to shift my paper up here so we got plenty of space. Plus x for the next term. And again, repeat the algorithm. X goes into 4x squared term. X goes into 4x squared. 4x times 4x divided by x. 4x times x is 4x squared. And 4x times 4 is 16x. Okay? Subtract. 4x squared minus 4x squared is 0. Perfect. X minus x squared is negative 15x. And then finally bring down our last term, which is minus 8. Give me a second to white out that little half a plus sign I drew. Look at that. It's like it was never there. And then we repeat the process one more time. X goes into negative 15x, negative 15 times. Negative 15 times x is negative 15x. Perfect. And negative 15 times 4 is negative 60. When we subtract, this cancels. And negative 8 minus negative 60 comes out to positive 52. Okay? Now, we're done, more or less. We've taken care of all the polynomial part of all this, but we didn't end with 0 like we did previously, which means we have a remainder. And I know what you're thinking. Didn't he say he was going to do remainders tomorrow? I said maybe. Here's a remainder. Now, here's how we have to handle remainders. Okay? The way we would handle remainders is, since it's positive 52, we're going to say plus 52 divided by this, x plus 4. And that's our final answer. Okay? Now, that's a long problem. I know it is. And there's like 8 like this on the homework, although I'm only going to ask you to do a few of them. But take your time, go back through parts of this video, watch it on your phones, watch it as a whole class if you guys feel like you all would benefit from that. And like I said, do your best. On your homework, the first 3 problems are just these guys, okay? Just these ones up here. And then, don't quote me, but there's remainders on the homework. There's remainders on a couple of the homework problems. So, don't freak out. Check your answers. Do your best. And remember, I will be back very soon to help guide you guys through this stuff. So, good stuff. Thank you guys. And like I said, go back and watch this movie again if you need to. All right, we'll see you soon.